question says that let a be the greatest value of the function fx, which is equal to log to the base x, greatest integer of x, and b be the least value of this function gx, which is mod sin x plus mod cos x. Then what is the relation between a and b, right? So we have to find the suitable relation using different operators. So let's solve step by step. Firstly, we'll solve a by solving fx, then we'll see b, right? So let's first solve what is a. So our fx is this thing. So now we can see that there is a variable on the upper part also of log and at the base also, right? So now we have to, so we cannot directly put some random number in log. So both the upper part and the base must follow some certain rules, right? So for base, the rule is that the base must be greater than 0 and base cannot be equal to 1, right? And for the value of the log which we have kept inside, that is greatest integer of x must be greater than 0, right? So these are the basic things which we must know for the base and value. Now, so one more thing which we can note is that x doesn't lie in the interval 0 to 1. So how we can say that? Because we already said that greatest integer of x has to be greater than 0. That means that greatest integer of x cannot take any decimal value also between 0 and 1, right? 0.8, because it will round down to 0. So we cannot do that. So it has to start from 1, right? But can it be 1? Again, we set another condition that x cannot be equal to 1. So now what is the real range of x? Okay. So x can take any value which is greater than 1. All right. Okay. Interestingly, when we see this is a special case, right? When x is from 1 to 2, greatest integer of x is 1, which makes the log to be 0, right? So this was a special case which I kept aside. Okay. So now we have broken x greater than 1 into two parts, that is when x is between 1 and 2, right? And another part when x is greater than equal to 2, right? These two cases are possible. So now we'll look for the generalized case. After 2 we can generalize the function, right? So let's assume we are generalizing it between an integer n and n plus 1, right? It can be either 3 to 4 or 4 to 5, right? Okay, so we are, because we are having a greatest integer function, so we have to generalize it in terms of integer so that we can make sense of the function. So now in this interval, the greatest integer is going to round down to n. So it is going to be equal to n, right? And we make sure that n is an integer firstly, and it is greater than equal to. So now what fx becomes in this generalization? Fx becomes log n to the base x, right? Okay. So now here also we get two cases. What if n x is directly equal to n? Then the f of n is going to become 1. And when x is greater than n, fx is becoming log n to the base x, right? But now we are saying that this thing is less than 1. Okay, you need to have a very close look. Why we are directly saying that it is less than 1? Because it is again the property of log. Whenever log comes in the question, we need to closely look at the properties. So we can see that the base is always going to be greater than the number, right? So why we are saying that? Because our interval is from n to n plus 1, and whatever greater value which we put from n, right? So x is always going to be greater. For example, we put n as 4 and on base we put 4.5, right? So in this case, since value of x is greater than the value of n, this represents magnitude, not modulus right now. So this log is always going to be less than 1. That is the property of log, right? All right. So on each interval, we notice that fx can either be equal to 1, where we ensured from this part, and fx can be less than 1. So by combining, we can say that fx is less than equal to 1, right? All right. So therefore, the greatest value of fx is 1, because fx is from minus infinity till 1, right? Whenever you have a problem in inequalities, you can write it like this using brackets. So now you can get a clear idea that the maximum value that the function can take is 1, right? So a is 1. We found our a because we had to find the greatest value. Greatest means maximum. So the question is using different words and trying to confuse it, but greatest already mean maximum. So we can say it the same. So now we have to find b. So now let's come to our gx. So gx is this mod sin x plus mod cos x. So what we can try to experiment by this? Like whenever this thing comes in our mind that sin x and cos x are together, that too in addition, we try to think of sin square x plus cos square x, right? Because we know there is an identity where it is equal to 1. We somehow try to make it into a constant because we don't like to deal with modulus all the time, right? All right. So we are just going to square this thing, and we are going to ultimately find that it is equal to 1 plus sine 2x mod, right? And now we know that modulus of any sine theta is from 0 to 1, right? Because modulus cannot take negative values. So when I okay, so now when I substitute it, okay, now I also have to add 1 because make sure that we are dealing with 1 plus sine 2x. So then we finally find that mod of sine 2x plus cos x whole square is from 1 to 2, including both of them. So for our simplicity, let's take this thing as t, right? So t square is from 1 to 2. Now what we have to do is basically separate these intervals into two different intervals and ultimately make sure that we take an intersection of it because it must satisfy both things simultaneously. So I've broken it down to t square greater than 1 and t square less than 2. All right. So I've used the number line method to further evaluate the intervals in which t belongs. So we break down the roots minus 1 1 and minus root 2 2, right? And then we'll see that since here it is greater than equal to 0, so we'll take all the plus part, and here we'll take the negative part, and we'll include both of them because there is an equality sign, so we use the square brackets, right? Okay, so now we have to take the intersection. Okay, so okay, one thing which we must know that t can't be negative. So while evaluating the question further, we have to take a note that what was t? T was mod of sin x plus mod of cos x. So can this thing will ever be negative? No, it can never be negative, right? So we'll automatically eliminate these things. Okay, so now after eliminating the negative part, we get this thing t belonging from 1 to infinity intersection 0 to 2. So now we again have to find the intersection. So one way of finding intersection can again be possible through number line method. So we'll plot all the things on number line, whatever numeric terms we can see. And then using this method, we'll see what are the intervals. So one interval is going from 0 to 2, and one is saying that it is going from 0 to infinity. So what is the common part? The common part is from 1 to 2, including both of them, right? So now we can say that t minimum or mod sin plus cos x is from 1 to root 2, right? So b was minimum value of this interval. So t minimum is 1, so b is 1, right? So interestingly we find that both a and b are equal and they are equal to 1. So there was no directly 1 involved in the options, but C is our correct option.